Okay. Now it is recording. Okay. Please go ahead and start your questions if you have, or you want to understand something. Yeah, feel free to ask. Michelle, Karam, Jesus, anyone having any question, any comment, anything, please feel free to ask. Yeah, don't hesitate. I'm here to explain. I'm here to answer your question. Whatever questions you have, please don't be shy. Yeah, even basic questions you have about anything, I'm here to explain. Hello. Okay. Okay, now
Hello.
hi.
Hi. I do have a question, and
Yes,
it's about the module two, fill in the blank.
module 2. Okay, previous module. Okay.
Yes, yes. I had a really difficult time on starting on question 33 on how to figure the percentages. It was asking for the range of age for like the 25% of passengers or the 25% of the fare and the pound variable.
Mm,
Anyway, the percentage part, this was something I was having a hard time with. Maybe you
yes.
can explain to me.
Yeah, I think I explained in the last class, but you asked, so I'm going to do here right now. So I'm just sharing my whiteboard. Mm, okay. Hope you can see my whiteboard. So basically, can you see my whiteboard? Uh,
Yes.
Okay.
Yes, I can.
So basically, if you have a data and you arrange in a order, so let's say this is minimum value, this is maximum value. Okay. So if you arrange this data, you take median, which is median is 50%, this divide data into two part. So this is first 50%, this is second 50%. Okay. Now you divide this data only from this median to max. Take the median of this. So this is this, and from minimum to median, take the median of this. So this is Q1, this is Q2, this is Q3. Okay, so Q1, Q2, Q3. So this is first 25%, this is second 25%, this is third 25%, and this is fourth 25%. So this data has been divided into four equal parts, and these parts are called quartiles. And this is the limit of Q1. So this is Q2, Q3, and minimum and maximum. So these five numbers, if you have these five numbers of your data, that you can easily get in if you go I mean, using Minitab, you can get minimum, maximum, Q1, median, and Q3. Now the question comes, what is the top 25% range? Top 25%. So basically, this is top 25%. And what would be the value of this? Maximum minus Q3. So whatever is the value, let's say maximum is 100, Q3 is 75, and this is the total is 25. What is the value of the second quartile? Second 25%. So second 25, this is median, whatever is the median value, and then minus Q1, and you get the value. So, I mean, any question related to that, if you have the data, you just put into the mini tab, and I can demonstrate over there. So, I mean, getting these numbers, minimum Q1, this, but when the question is framed, they are framed whether this is first quartile, this is second, this is third, this is fourth. So you are asked the question related to this concept. Is it clear, or is it making sense? Am I able to answer your question?
Yes, but how do I do it in the Minitab? That's where my problem is. I might have missed something in Minitab
Yeah.
where it wasn't calculating it.
So actually, I demonstrated in the last session, and I'm going to show you again. So 1 minute.
Oh, yes, please. Thank you.
So even I shared the recording. Yes, I mean I also shared the recording with you in the announcement section. Can you see the My Mini tab? When let me see data. Can you see my mini tab?
Yes.
Yes, yes.
Okay. So here, I go under statistics, basic statistics, descriptive statistics. Let's say I want to fair in pound. So I selected the variable. It only gives when I do the descriptive statistics, it will only give the value variables which has numbers. So you can see the fair in pound. This is the numerical value. All the values are numerical. Age is numerical value, and male and female, because it's a binomial. I mean, male or female, 0 1. So here this is, therefore only you can see three variables here. Now I see the statistics. Now I have the option statistics. Now whatever, let none means, now whatever I need I can put. So this is the minimum value this is the maximum value. Okay. This is a first quartile, which is Q1. This is a median, and this is a third quartile. And now you get the all 5 point numbers here. Can you see this? Now you have minimum, maximum, Q1, median, Q3. For any variable, you can do like this. Is it making sense?
That part so far so good.
Okay. So, yeah. Any other question, please? Okay, I'm going to explain then, few basic concept related to this probability. Because discrete probability and continuous probability. So these are the two chapters we are covering in this module, and I think this is the most difficult module um, in two courses, 503, BADM 503 and BADM 520. So let me explain basic concept, and then you can and you can go through the slides and you can go through the recording, since no one is asking any questions. So let me explain from my side. So let me start with whiteboard. Okay, can you see? Okay, now you can see my whiteboard. Let me erase this. Mhm. Erase. Okay, clear page. Now let's look into the first I mean, we are not covering uniform distribution. Uniform distribution means everything is uniform. Now we are starting with binomial. So basically, we are going to do three or four distribution in chapter number 6. Before starting chapter 6 and chapter 7, let me explain the difference between these two things. Chapter 6 is about discrete and chapter 7 is about continuous. What is the difference between discrete and continuous? Discrete means 0, 1, 2, 3, 4, 5, 6, 7, 8. I mean, these values are possible in discrete. Let's say if I say there are 12.5 cars in parking lot, which is not correct, because either it can be 12 or 13 but not 12.5. So those are the possible values, integer values. Basically, discrete means, so here our x value will be 0, 1, 2, 3, 4. Continuous can be in decimal also. For example, the average age of the class is 28.5 years. Okay, that's fine. Average weight of something, in decimal. Average distance is this. So any any value that has also decimal value, that is continuous, means any value is possible. So in continuous distribution, we are, so here we do the probability of event 0, event 1, event 2, event 3, 4, or out of these events, means x value we we need to identify. Here we check the area. In continuous, we check the area. So what is the area between, let's say, 0 to 1.1? So we would like to see this probability on normal curve. In even this area, so basically in continuous distribution, this is the. So if you understand the discrete and continuous, let me start with chapter number 6 first, and let me briefly explain all the all the uh, distributions. So let me clear this. Is it clear what is discrete and what is the continuous? Now let's. So number one is binomial, that is important. Second is Poisson. Poisson. Third is hypergeometric. Fourth is geometric. So these are the common, things, but there is also how binomial can be converted into Poisson. That is another case. Let's do this. What is binomial? Binomial, you have only two possibilities. So how to identify the distribution in the question? You have two options only, let's say, and which are opposite to each other. Let's say yes for simple reason, yes, no, success, failure, doing, not doing. So if you see this kind of situation, let's say 20%, let's say I'm just giving 20% of Washington residents are having health insurance. Okay, health insurance, having health insurance, what is the meaning? 80% of Washington residents don't have don't have health insurance, not having health insurance, just for example. So 20%, uh, there is 50%, 15% chance that I will go for my car service oil change. Then what is the chance that I will not go for car oil change? Which is 85%. There is a 40% chance that I will get this job. Let's say if I get I appeared in an interview to get a job. Let's say 60. Then what is the chance? 60%. No chance of getting job. So basically, whenever you see such kind of situations, you apply binomial distribution. How to do? We are going to. And most important thing in binomial distribution, you have to identify three things. One is pi value, proportion. Third is n value. Second is n value. Third is x value. So if you are able to, so pi will be given, n means sample size is given, x value, like we know the x equal to whatever value, 0 event, 2 event, 3 event, we are going to see. So in binomial distribution, what is this pi? Let's say this is, for example, I will go for car oil change. This is 20% chance. So this is pi value. N means how many samples? So this is, let's say, 12 samples. What is the chance that you know 2 will come or less than 2 will come? So here n will be sample size and x value will be like this. So this is binomial. Then I'm going to demonstrate on Minitab. Now, if you understand this thing, let's do one example that is there in this uh, slides, so you will understand better. So I'm going to share my screen too. Are you able to see the sorry. So discrete probability distribution, actually, this is, you can understand, but most important thing, binomial distribution. So basically mean is this. So basically, if you look into this slide, there's a this kind of summary slide of each distribution. So look into that. You can use a Excel also, Excel function. So in case if you are doing cumulative one, you can use here one. If you are doing simple, you can use this. What is cumulative and what is uh, simple probability, I will explain in a minute. So look into, okay, can you see this example? On average, 20% of the emergency room patient at particular hospital lack health insurance. So there's no, 20% lack. In a random sample of 4 patients, what is the probability that at least two will be uninsured? At least two will be uninsured. Before that, I would like to go into this because that is a cumulative probability. So, what is the probability that exactly two of the next 12 car service are late? So, we would, there's a probability that 10% cars are late. So, the pi value is given 10%. What is the probability? Next 12 cars, 2 will be the late. How we can see this probability? So very simple. So I go here. Can you see my mini tab?
Yes.
Okay, perfect. So here under graph, we have under graph and probability distribution plot. So here this is a probability. You can same find here and you will have all the distribution right here. Now what we are going to look into the binomial. Number of trials, how many? There are 12. What is the probability is 10%. Event probability, which is pi value, n value, this is n, this is pi. Now we need to find the exactly 2. So I put here, 2. Since this gives the cumulative, so we will get the cumulative result, but no worry. So here you see this is the, if you look into the bigger picture, this is for 0 equal x equal to 0, x equal to 1. This is 2, 3, 4, 5. So exactly put on the 2 value. 2 is 23%. What is the value? 23%. What is the probability is 23%. Put together 2, 1, 0, the total probability is 88.91. Now this is the same thing I'm going to do using calculator, and here we have a probability distribution and we have binomial right here. Look into, I'm going to do probability, number of trials are 12, event probability is 10%, and input constant is 2 because x equal to, so this is x value, this is probability, this is n. Now we can get exactly this. So if you look, so I hope you can see my numbers, 23%. Let me make it bigger. Okay. So if you can see this, now let me go to demonstrate one more thing right here. Give me a minute. So hopefully you can see my distribution table. So I'm just going to pull the table. These tables are given at the uh, end of the book. And you can see basically when I did not have these computers and sophisticated tools like all these softwares, I used to do using this table because for me this was availability. Can you see this? Now here, can you see the table? Yes.
Yes.
So look into here, you have n value, this is x value, and this is p value. So what is our P? First you look into the P value. P is this 10% right here. Now look into the N. What is your N? N is 12, 11, and 12 is N. And I think this is the 10%. Yes, right here. So N equal to this 12. Now look into the X. So this is X value, X equal to 2. This is the 2. And this is the right. Can you see this is the answer that we got? Is it making sense?
Where do we find that table at again?
So table is right there at the end of the book, or you can download anywhere from anywhere. I mean, just do the binomial distribution table and you can get the table. And every book has at the end, you can go into the appendix and you can see the binomial table right there in our book. So this is 23%. Now this is the probability of zeroth event. When 12 n equal to 12, this is for 1, 2, 3. So, so this is one thing. Now let me go back. I would like to explain what is the cumulative probability and what is the. So two things you must understand. Okay, so here, you can see my Excel, and what I'm trying to do, I'm going to explain PDF concept and CDF concept. What is PDF and what is CDF? PDF and CDF. Look into that. So basically, PDF and CDF, this is cumulative value and this is individual value. Let's say we get salary every month. So January, Feb, March, April. Can you see my Excel? May,
Yes.
June, July, August, September, October, November, and December. So, for example, some people have little bit variability based on different performance. So every month, some fixed income, some, let's say first month somebody got 10,000. Second month got 11,000. For simplicity, I'm, using simple numbers, not decimal, or again got 10,000, 11,000. This month he got 9,000. Here 12,000, 10,000, 11,000, and 10,000, 10,000, and 10,000. So this is the salary someone is getting over a month. So this is now cumulative. What would be here? First month 10,000, 11,000, which is 21,000, plus 12,000, 33,000, plus 10,000, 43,000, plus 11,000, 54,000, plus 9,000, 63,000, plus 12,000, 75,000, plus 10,000, 85,000, plus 11,000, 96,000, plus 10,000, 106,000, 116,000, and 126,000. So how much somebody has received total this? Now, what is the importance of this and that? I'm going to explain. So I'm going to draw a bar chart based on this. So where is a chart insert recommended chart? And I want to see this. And let me put the, okay, let me put the data levels. Okay, here we go. So this is basically cumulative, that I want to know the salary of someone in July month. What I can say using this, I can say this is 12,000. I want to know someone's salary in April, it's the 10,000. March. So if I want to know a individual salary in particular month, I can use this. Now, if I want to know what is the salary somebody got after July, after July means it is not July. After July means August, September, October, means these 5 months. So I have to add 10,000 plus 11,000 plus 10, 10, 10, and I have to sum all and to get 51,000. And this is little bit, 5 steps process, or adding five, knowing first five and then adding all of them. So for that purpose, or what is the value, what is the salary somebody has got before July? Before July means up to June. So I have to do this June, May. I have to add all previous 6 months to get this number. But for that purpose, if you use CDF, it's a very simple, and that you can see here. Now, let me put the numbers at data levels, and here we go. Now my question same. What is the salary of someone before July? And you don't need to look much, and you can get the answer right away. Before July, you just see on this month and you will see 63,000. Isn't it? If I ask what is the salary of someone after July, so I don't need to do this. I have total number 126, subtract up to July, which is 75,000, and I can get the answer. Isn't it? So this is the easiest way to do. So cumulative is this, cumulative probability is same this. How do we get? So this is the importance of cumulative probability and simple as, and so same numbers I can get in Minitab instead of table. So I'm going to show here. So look into this table. I'm going to make, so I'm going to event, I'm going to put X value. I'm going to 0, 1, sorry, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So these are the X value I put, and I put PDF and I put CDF. Let's do this for the same example. Same example that, I use calculator, probability distribution, and binomial. So first, probability means PDF. Simple, so number of trials is this, 12. Event probability is this. Input column is right here, which is, I can say from X, I can see where to store. So I'm going to store my results in PDFs to know the value. So this is a PDF. So you can see what is the value that we got here. I'm going to do the CDF. So statistics is, sorry, calculator and binomial again. And then I'm going to just change this cumulative, and I'm going to store this into CDF option. Nothing. And you can see this is, can you see this? So if you see, so actually this is our answer in previous case, 23%, isn't it? Look into these numbers, and I'm going to show you the, so 28%, 37, 23, 8. Look into the same. Okay, here we have n equal to 12. Where is the, yeah. So look into 28%, 37%, 23%. Same table you can create in Minitab just by clicking. So basically, this table is nothing but telling you the numbers exactly. And I used to do when I was, in school and college to study statistics. This was the way to do. We did not have the computer and calculators. So how to get? So basically, either way you can get the results. You can get using the tables. You can get using the calculator, computer. How to get the same results in Excel? I can demonstrate that too. So in Excel, here I just put equal sign, binomial, and I put distribution. Now clearly the return here you can see, you know, numbers, you know, trials, probability. So I am going to take 2, number X value is 2, then 12 is probability, 12 is, n sample size, probability is 0.1. Now for cumulative, you put 1, and for simple, you put 0. So I'm just going to put 0. And now you can see exactly 23% value is right here. So doesn't matter, but it's easy to visualize in Minitab. So this is the so so here if you see the Minitab, this is the value of 0, 1, 2. So how the value is changing. So this is binomial distribution. Okay. Now in binomial you have two options, and they call it compound event probability, and so let me show you. So basically this is, you can see here, 23% exactly. Now, yeah, this is the question. What is the probability at least two will be uninsured? So what it is asking, at least two, means it is asking cumulative or compound event CDF value 2, 3, 4. So x and pi equal to given 20%. So now x value is this, but it is asking at least two. So 2, 3, 4 means we want to check all these numbers together, total probability. How we can check? So, if you want to use Minitab, here I can, so here 4, 2, and 20%. I can do in just one click. So graph probability distribution and look into that. Number of trials are 4. We are looking for 2. We are it's a 20%. X value, we are looking for this side of graph. X value is 2, and now we get the 18% because it is 2, 3, 4, all the values above. This is, in one way, in one click, you get the answer. But I want to do using our traditional method. So look into the table. Sorry, base table right here. So what is the n? N value is, so first you look into the n value. N value is 4 right here. X value is, and what is asking 20%. So this is, can you see, this is 20%, this is 4. Now look into this column. It is asking 2 and more. So what is the 2 and more? So this is for 2, this is for 3, and this is for 4. You add all three, 15% plus 2.5%. So basically 18 plus some percent. So you can see more than 2, this plus this plus this. At least 2 means 2, 3, 4, whatever on other, on higher side. If the question is asking less than 2, what is the probability of less than 2 are insured? Less than 2 means 0 plus 1. So 40% plus 40%, which is about 82% are uninsured because this value plus this value. So if you see this, and the answer is for this, because probability of 2, probability of 3, probability of 4. So this is no more than 2% have, so it is 0, 1, and 2, and total is 97. So basically this is called compound event probability. In compound event probability, we have to understand this slide very much. So I would suggest you, because otherwise you can put a wrong X value C26. This is sorry. This slide is very important to understand. What should to decide what should be the x value. In this, you don't get confused about pi value or n value. Only the x value. So if I ask at least 2, means it is asking 2, 3, 4. Fewer than 2, it is asking up to 2, means it is asking 0, 1 and 2. Up to 2 means it is fewer than 2 or more than 2. Fewer than 2 is 0 and 1. So discrete means you have 0, 1, 2, 3, 4. If it is asking less than 2, it is not asking 2, it is asking before values. So there are two, PDF and CDF. If you understand this part, it's easy to do rest things. Means Poisson distribution has different nature. And so any question do you have related to binomial distribution? Any question? No. Okay. If you don't have, the next distribution is so basically Poisson distribution has two things. One is simple distribution, so and compound, or which is CDF and PDF. Okay, now the second distribution is Poisson distribution, or basically this is third distribution. We are not covering uniform. It is basically a average. And average is demonstrated by lambda. So let's say in particular hour or particular time, or let's say in a hospital in particular hour, on an average 20 patients arrive in emergency per hour. Or let's say on airport, 8 flights arrive on the terminal every 30 minutes. So if you look into the average situation on minute, hour, or on uh, space, then you can understand this is Poisson distribution. Okay. So how do you recognize when you see something average is given related to space, related to time, minute, hour, or day, month, year, whatever? Then you can understand that this is a Poisson distribution, and you can see lambda is average and square root of lambda is standard deviation. Now look into that. Uh, so here most important thing is lambda. You should know the average thing first. Once you know the average, then x value, put the correct x value and get the number of probability. So if lambda value is given in hours and question is asked in minute, then you have to convert either demand into given information. Means both units should be either minute or hours. It should not be like lambda is given, average is given in hour and asking in minute, or minute to, it will be wrong. So make sure to convert the unit in same form. Now look into this question. So here is the 1.7 customer per minute. And here, what is the probability that two or fewer customer will arrive in given minute? And here 1.7, 9 a.m. and 10 a.m. Basically, this is 1 hour uh, at a 1 point per minute. So 1.7 per minute. So it is given in per minute. And the question is asking also in given minute. So probability that two or fewer. So two or fewer means it is asking 0, 1, and 2. So let's do this. And so I go and the graph probability distribution. Okay, and here I select the Poisson, where is right here, and lambda is 1.7, and it is asking x value is 2, and 2 is up to this, and look into that. So it is saying 0, 1, 2, total is 75%, and the answer is also, oh, so here you can see 75% the same. Now, what is the probability? At least three customers will arrive. So basically, it is asking 3, 4, 5, 6, 7, all above. Then how you can do? You can simply select, you go under graph, probability distribution, right here. Okay. And I put here 3 and more it is asking, and it is asking on this side. And look into that, and it is giving 24%. Same. And same thing you can do using this option also. Calculator probability distribution, right here you have, where is Poisson distribution, somewhere you will find it right here. So mean is 1.7. What is it is asking? Cumulative probability, input constant is 2, and here you can see 75%. So, and same thing you can do in table also. So here you can see the table. Now you see, the what is the highest n value is given in binomial. So binomial highest n value is given 20. Same thing is highest lambda value table is about 20. So what happened more than 20? When, if anything happened more than sample is bigger, then every distribution converts to the normal distribution. So the continuous probability distribution binomial converts to continuous distribution. So which is the next case. So here, and let's see, this is right here, and you can see, and now you can see this. So here you see the lambda value, and you can keep looking in the lambda value. 9, 8, 10, lambda equal to 20. After lambda equal to 20, there is no. So if lambda is higher or n is higher, all distribution convert into normal distribution. Now we were looking for this. What is the, so look into this 1.7, and it is asking up to 27. Sorry, x equal to 2 or less than. So look into, you sum 18% plus 31% plus 26%. What is the value? 26 plus 31, which is 57 plus 18. 57 plus 18 is 75, and plus, some, this decimal. So basically, you can see the same answer right here. Is it making sense? I mean, you are free to ask you or say or something that, is it making, or just I'm keep saying. Are you getting or not understanding something?
It's making sense. Thank you for your explanations.
Yeah, most welcome. But ask the question so that I can explain more. Actually, I prefer dialogue instead of just, keep explaining. So, okay, this is the second thing. Now, third distribution is hypergeometric distribution. and which is here. Now hypergeometric distribution is, having, it's a it's a similar to binomial distribution, but it has finite population. Finite population is capital N. Means, let's say Eastern has 10,000 student. So 10,000 student is a Eastern population. If I take 100 students from MBA, that is, out of 10,000, students are samples. So a small n is a sample, capital N is population. So here we do based on that. If you have capital N is number of items in population, small n is sample size, and number of success in population, and then you can do the X value. So here nothing but capital N is given, means finite population is given, that okay, there are 5,000 uh, insured uh, customers, out of that 12 are taken or 12 are considered. So this is the, and PDF, CDF, everything is right there. This is very important rule. I will come on that. Now look into this, a case where they are considering a defective products. In a shipment of 10 iPods, 2 were damaged and 8 are good. Okay. So basically, any shipment, the receiving department at Best Buy tests a sample of 3 iPods at randomly to see if they are defective. So 10 is capital N, which is shipment is 10 iPods. How many sample? 3 sample. So 2 were defected as equal to 2. Now we want to see how many are. So in 3, what is the probability that 0 will be defective, 1 will be defective, 2 will be defective, or 3 will be defective? So I go under my, same thing you can do, uh, graph probability distribution, and now I go for the same hypergeometric option. Here is hyper. Now here you see 10, sample size 3, and event count 2. So population, event, sample size. Now we would like to see all 3. What is the probability that all 3 will be? Now I just use this. So look into that. And now you can see. So, if you see 3, you took 3 sample out of 10. What is the probability that out of 3, nothing will be defective? 46%. 1 will be defective, 46%. 2 will be defective, 6, about 6% something. Or, cumulative. So this is a cumulative. So look into that one, at least 2 defective, or, 2 up to 2 defective, up to 1 defective is 46 plus 46 something. So this is the way we can do. So here you can see the answer. Yeah, so basically and this is 0 equal to 46, 1 equal to. So what is the difference between this and binomial? Binomial has, binomial doesn't have the finite population, it has finite. Most important thing, this distribution can be treated as a binomial distribution. Why? So basically, few question in MCQ or fill in the blanks, when small n divided by n means sample divided by sample is such a small as compared to population, then it can be treated as a binomial distribution. So let's say I'm taking 30 sample out of 3000. 3000, sorry. What is that? This is, you know, 0.01, about 1%. So third, then I can treat this. If I'm taking 30 sample out of 3000, okay, I can consider this as a binomial distribution. So please remember this condition. Approximately binomial is as success divided by, so the pi can be, what would be the proportion? Because for binomial you need a proportion. Proportion is pi equal to success divided by population. And if this is the case, you can consider, instead of hypergeometric, you can consider the binomial distribution. So now we, sorry, actually it will take, okay. So this is the another distribution. Now we have one more distribution in this chapter, geometric distribution. So the geometric distribution is, Bernoulli trials until first success has achieved. So let's say something is happening, like you organize an event for fundraising in university. What is the probability that seventh person will donate, or will donate some money? So basically, this is the geometric. So until first success has been achieved, and it is like, so here, at this university, 15% of alumni make a donation or pledge during the annual. What is the probability that first donation will come on seventh call, or seventh person will give the? So this is geometric distribution. And here, you can clearly see, and we can do this in Minitab also. So here we go, graph probability right here, and shaded area. Sorry, we need to check this geometric. Okay, event. What is the probability? Is 15%. And now shaded area, and we are looking the seventh person. So here is the, so basically we have to look into the seven. I mean, I have to, because it is giving the cumulative. The on seventh person is about 5%, 5.6%, or 0.056 for seven. And you can, so this is the answer. So 0.056. So this is, and so this is the chapter number 6. Chapter 6, most important slide is this, to check which x value you are going to use, and fewer than, more than, you can check. Is it clear to everyone what we are going to learn in chapter number 6? Discrete means x value is always 0, 1, 2, 3, 4, 5. Integer. Any question? If no, do you want to go for chapter number 7? You want to understand something related to chapter 7? Feel free to ask. Because it will take, yeah, you don't, no question. because these exactly the same videos are recorded and shared over there. So whenever you feel you need to understand, you can rewatch. But let me explain one or two things right here. So here we go. And what is about, chapter is 7 is continuous probability distribution. So how we can see, basically we are going to talk about normal distribution. So I go here, I do the normal distribution, which is right here. For standard normal distribution, mean is always 0. Standard deviation is always 1. Okay. Here you can see the x value. So let's say, empirical rule that is in chapter 4, I'm going to explain here again. So empirical rule plus minus 2 sigma. Okay, I want to check, this value. Plus minus 2 sigma. How can I see? So 1 minus 1 and 1. So plus minus 2 sigma. So minus 1, this is 68%. You can see 68%. Okay. 1 sigma this side, 1 sigma this side. Now 4 sigma, I go here and I do the probability distribution. Same thing. And I do here minus 2 and plus 2. This is 95.44. So you can see this is 95.45. Now third 6 sigma minus 3 and plus 3. Okay, and here we go 99.73. So this is empirical rule. And most important concept of chapter 6 and 7 is right here. This slide is very, very important. This, unlike discrete distribution, the probability at any single point is 0 in continuous distribution. Remember, if I ask what is the probability on 1 in continuous distribution, you blindly say 0 because that's a 0 by law, by rule, by it only gives the area. So whenever you see area between 2 points A and B, so in this chapter you always look for area. So here, you look for the area, different areas. Mu is mean, sigma is standard deviation. So this is a normal distribution curve, and cumulative is like this. So it has z value is this, and whatever value you want to check, you can check. Let's say, for example, in this is class, uh, in this class, we have 100 points exam, entire 100. In past, let's say if I see past um, 510 section, the average score in this class is 90. So I go and graph probability distribution. Oh, I go here, average is 90 with a standard deviation is 5. Okay. Now I want to check if I score, let's say 92, in what percentile I will be. So when I look into this, since 90 is already, so this is 65 percentile. My score will be 65 percentile. And if same question, if I ask, what should be the cutoff point of 95 percentile? So how I can check? I can go here, probability distribution. Okay, and I can do right here and I can do probability and I can check the probability for 95, or I can do this 5% or 95% either way. Let's say 95. So if somebody scored 98.22, he will be in or she will be in top 5%, top 5 percentile of the course. So basically this is the way to do in this. You need to have mean, you need to have a standard deviation. When you have these things, you can get X value or you can get corresponding probability. Any question, please feel free to ask. Or anything you want to understand, please feel free to ask. I'm here for. Because from my end, these are already recorded. If no question, do you want to say have a wonderful evening, wonderful night, and have a wonderful productive week ahead? And we will see again on next Tuesday at the same time, 6:15.
Thank you.
Most welcome. But yeah, if you have any question, let me know. I will be happy to, explain in the class, because if I don't see the question, then I see you understood everything. Okay. I have
Thank
a
you
one.
for explaining.
Most welcome, sir. And okay, wonderful evening. Good night, all of you. And I will share this recording. Okay. Bye bye.